Hello, everybody. Welcome to this month's Specifying Practice community. But with that, then, I do want to hand it off to Dave and Lewis to get started today, as well as one of our guest speakers today coming in from Elias Saltz. I'll let Dave and Lewis introduce him and get going with today's topic. So, Dave, Lewis, and Elias, over to you.
Okay, great. Thanks, Matt, and thanks everyone for joining us today. And as Matt mentioned, this is Dave. For anybody that doesn't know, we have a guest with us today, Elias Saltz, coming to us from Chicago. Thank you for joining us, Elias. Appreciate it.
Hi, Dave. Lewis. Good to be here.
And Lewis from beautiful downtown Nashville.
Well, actually, suburban Hermitage.
Okay, so Lewis,
high atop the Medcalf Manor in the second floor bedroom.
There you go.
My office. So
why did you choose this topic for today, Lewis?
Because this subject is getting awfully confusing, and I was hoping that you and Elias would get me straightened out. You know, it used to be pretty simple, and you just had steel studs that had plain surfaces, and they were galvanized, and now we got dimpled studs, and we got studs made out of different strength steel, and studs that have different kinds of coatings on them, and just all kinds of new stuff coming on. And then so I thought it might be a useful topic for us to thrash about a bit and see if we can figure out what kinds of decisions need to be made and by whom those decisions should be made.
Well, and we've seen a lot of, I'll say recently, although it's been going on, I'll say probably for about a year, discussions with our own clients about what to do with steel stud specifications. And part of the reaction has been to take I'll say an extremely conservative approach and simply say, hey, we're going to pick the heaviest stud available, and that's what we're going to use, and we're going to use it everywhere and require the contractor to buy the most steel that he can and put it in the building. There are alternatives, and we try to present them to the clients, and it's a way to try to help perhaps improve performance, actually, and be able to help control costs as well. So hopefully we take a little bit of walk through some of the concerns that we're seeing in our discussions with our clients, and maybe you can share some thoughts that you have as we go along and try to help everybody get an understanding about what's happening in this wonderful world of steel stud framing.
Now, normally, cold form metal framing, you've probably seen it abbreviated in drawing notes as CFMF, but increasingly you see the initial CFS, meaning cold form steel. And I don't know how many folks are aware of it or not, but when sheet steel is cold formed with a rolling method or whatever, the forming actually changes the crystalline structure of the steel to a certain extent and makes it stronger than if it was hot formed. So we have studs we typically divide up between Division 5 and Division 9. And Division 5 are sometimes referred to as curtain wall studs because that's a very common use for them. And they would be axially loaded, but they have to resist the lateral load of the wind as well as holding up whatever lightweight cladding is being attached to them. And then you, of course, if you really have a true steel stud structure as such, which is a growing field, then they are axially loaded. And of course the steel stud manufacturers also make joists and other shapes, and they can be made into factory fabricated trusses for steep slope roofs and all sorts of things. We won't get into the trusses and some of the other things. And then we have in Division 9 the interior steel stud framing, and it's called non-structural, even though it may hold up some pretty heavy things like wall cabinets and give support to grab bars for ADA. Let's go to the next slide, and it gives us a definition of why of non-structural.
Well, wait just 1 minute. I want to go back to just on the cold form, and I know we're going to spend most of the time talking about the drywall type framing, but cold form also is not just actually and laterally loaded, but it's also acting as shear, especially when you're in a cold form metal framed structure. So it's taking all kinds of loads.
Yes. And we'll talk more about that. So the ASTM 645 actually defines what a non-structural stud is. And it's, as you can see here, there's limitations on the loads and so forth. So I've always felt that term was maybe a trifle misleading, but it's not holding up the building. It's the basic concept.
No, and we don't want to put a load on it, because if we do, it may get some bending, because you're talking about a very slender column, really. And if we do put a load on it, not only might it bend, but it could cripple, and that would not play very well for an interior architectural partition.
True. And of course, all interior studs and exterior studs too need to be isolated from the deflection of the primary structure, whether it's steel beams and girders that are deflecting or concrete creep for concrete frame.
Right. So what kinds of, Elias, maybe you can jump in here, and what kinds of ways are we trying to deal with some of this deflection that Louis just mentioned?
Generally, in terms of the non-load-bearing types of steel studs, there's three main options, generally having to do with the head track that gets actually attached to the structure above, where the top of the studs are going to be. So you have either a single track, which are just long tracks with long vertical legs that stick down, and then the studs are friction fit between the legs of the track. And then there's another option is a slotted track, which is similar to the long leg single track, except it has vertical slots cut into the track, and then the studs are screwed into the slots so that the slots allow the track to move up and down. And then for instances where you have expect a significant amount of deflection, a double track where there's an outside track which has a long vertical leg, and then an inside track which is basically attached to the top of the studs, and then they nest inside each other, allowing the top track to move up and down without crushing the studs. That's usually used for when you have a little bit more significant deflection expected.
And then there are some proprietary types that have, it's a single piece, but it's got a little crimp into it, so that as the load from above comes down, the crimp will kind of close up and allow that deflection.
Elias, and you've discovered another one today.
Yeah.
Well, do we avoid naming the names of the products, or?
Well, we can say it's a proprietary product, but if you maybe just describe it.
Yeah, it's similar to the one that Louis just described. It's crimped, but it actually has a track. Well, it's a piece of basically two studs nested within one another. The top one is crimped so that it nests inside the top track, which has a matching crimp, and then the deflection is accommodated by the it's hard to describe. You really have to see it because it was such an unusual kind of thing. But
you actually need to watch the video the manufacturer has on it on their website, because you won't understand how it gets installed without it.
yeah, right. So
But yeah, basically it's a system that the studs go into the top and the bottom track, and you twist them in place, and theoretically you don't even have to screw them because they've got enough friction fit that as soon as when you put the wall board up, everything's pretty secure. And like Elias says, there's a sliding piece in the top, so that it's one of the things they promoted for is older buildings where you may have some variations in the floor above or the structure, and this gives you a better way to accommodate that than traditional construction.
So,
And then to complicate things, there are manufacturers, well, we'll talk about that later, that have fire-rated top tracks for the rated joint systems.
So one argument that some of our clients have been making is that they're going to the heaviest metal stud that they can because of the kinds of loads that are being placed on the studs. And some of the loads that they're suggesting are lead sheet for radiation protection in a healthcare setting, or security mesh where it might be used. And the typical thing where we're seeing it is, say, in a pharmacy to protect the drug storage that they have. So I went and I looked at lead sheet. Most times we're using 1/8" lead or less. And if we're at 1/8" lead and we're at a 14-foot floor to floor, which is awfully common for the hospital work that we're doing, we're imposing about 100 pounds per foot. It's just slightly over 100 pounds.
And actually, many times, the lead sheeting doesn't have to go all the way to the floor above. It only needs to go up to 8 or 9 or 10 feet.
Correct, but looking at it as a worst condition,
in the worst case, yes.
the likelihood that we're going to exceed the 100 pounds a foot, even with that kind of a loading condition, is pretty remote. We haven't gone anywhere yet that I recall that's required more than 1/8" lead. So what is it that you want, Lewis? What are these clients really asking for?
Well, we've got a little checklist here. Obviously, we have to hold stuff up and resist lateral loads, and even interior steel studs have lateral loads. We especially think about shaft wall for an elevator hoistway, and if you're in a building with a high-rise elevator that's going to go 700 feet per minute, you can get a very appreciable amount of air compression on that wall, and so it needs to be designed exactly for that. Code basically requires that unless there's something like an elevator shaft, the minimum lateral load is 5 pounds. But then one of the other things is people's comfort level in terms of the horizontal deflection. Some years ago, I worked on a project that was remodeling an old multi-story hardware warehouse in downtown Memphis, Tennessee. So the ceilings were very tall. They were 12, 14 feet. And the steel studs that went in, the walls bounced a bit, and it was not real comfortable for people when they lean up against a wall and it, bows an inch or something like that, or when they're hanging a painting and it, and they hit on it and the wall bounces around. So we want to try to control that, and of course that's a critical item. If any of you ever designed an office for a chiropractor, because there are some of the chiropractors will throw you against a wall as part of their manipulation of your spine, and again, you need to control that deflection. And then we have the building movements, vertical, horizontal. We have building sway that has to be taken care of with the exterior studs. Acoustical separation, fire and separation, and then, of course, resisting corrosion. I want you to talk about that a little bit, Elias, because that was one of your items that you contributed.
Yeah, well, the specifications that we write for, and in fact, the standard specification, the ASTM standard for steel studs, requires that steel that's being made into stud have a corrosion protection coating on it. Generally, it's a hot dip galvanized. The steel is rolled through a galvanizing bath before it's made into studs. The G40 rating is the minimum amount of galvanizing, which refers to a 0.40 ounce per square foot total on both sides of the steel. So then the other ratings are G60 or G90, providing higher level of corrosion resistance. And then there's also proprietary, what's called EQ coatings, which have less zinc coating, but then use a proprietary organic or other products that essentially provide equivalent amounts of corrosion protection to a G40 and are therefore permitted under the ASTM standard and the ICC code.
So I want to just touch on the acoustical separation, because some of the concerns that we hear from our clients, again, going to that heaviest stud approach. So they're taking the 33 mil drywall stud and applying that at 16-inch centers, but they're still expecting it to perform acoustically. So if you go and one of the resources that we use for acoustic performance for gypsum partitions is the fire resistance manual that the Gypsum Association puts out, GA 600. And if you read the preface of that manual, the acoustic testings that are shown in that manual are based on 18 mil studs at 24 centers. And the rationale is that if the framing is light, it can absorb the resonance from the acoustics, whatever sound is being generated, and actually transform it into heat. If it's rigid, more rigid, it's going to transmit the sound through the assembly more readily than absorbing it. So by simply moving to a heavier stud, you already are decreasing the acoustic performance of the partition. And by putting the studs closer, moving from 24 centers to 16, you're also reducing the performance, the acoustic performance. So if you're looking at GA 600 and you're saying, oh, okay, 3 5/8 studs, double layer of gypboard both sides, and I'm going to get a STC 45, remember that you have to look at what gauge, mill thickness.
You're showing your age, David.
I slipped. Sorry, I slipped. What mill thickness and what spacing those studs are going to be, because it will have an effect. We've actually encouraged some of our clients to go out, because they're building the same building types routinely. Say, do field tests. The field acoustic tests really are not all that expensive. And if you're going to be relying on these assemblies, and you have to meet things like the code for residential where it says STC 50 or facility guidelines, right, or facility guidelines where they're looking for potentially even greater acoustic separation
for healthcare,
right? So that you can't just make this stuff up, because somebody's going to complain if it's not performing once it's built. and then you're going to have a real problem trying to figure it out and trying to fix it.
One of the things that one of the firms I worked for a while back was a leading designer of hotels across the country, and we always specified to do a full mock-up of a guest room, and then we field tested it before they could build the rest of the rooms to make sure that the design was going to work and they were going to get that acoustic separation, which is so critical to the tenant or the client satisfaction.
Especially a 5-star hotel.
Yes. Especially that. So, who designs steel studs? Well, the structural studs almost always are specified as delegated design by a PE that's employed by the contractor, or really typically the steel stud manufacturer will provide that surface. But there are regions, David tells me there are regions of the country where structural engineer of record will typically design that stud framing.
It's especially West Coast, where there's a big concern with a little bit of seismic activity. We see this very much as a East Coast, West Coast phenomenon, where West Coast, the structural engineer of record, will design exterior cold form metal framing, and East Coast, they rarely will design it.
The advantage of having a delegated design by the actual steel stud manufacturer is all the manufacturers of that product have a lot of proprietary products for headers and bridging and one thing and another that they've made, that the way they compete with each other is to make their system more convenient. And if you know all those things, you can save a lot of money by utilizing them.
So what if we go to the non-structural stuff?
Yes.
Who is going to design those?
And that's an interesting question. Again, it gets back to that user satisfaction. And I had the best intentions of coming up with a poll question on this, but didn't do that. So let's, but if everybody will cooperate by raising your hand, if you'll notice on your little go-to webinar thing over there, there's a hand, a column next to your name. And if the most common, how many people most commonly allow the contractor, which means in effect the drywall subcontractor, to select the interior studs? Can we see a show of hands? What's the?
Are you saying allow or require?
Well, you don't control it, so that's how it happens.
Okay. Well, with the response, we maybe have 40% saying that they allow the contractor. We actually have some clients that require the contractor. It is a delegated design item for the interior framing.
Well, this, how many, if by a show of hands, actually select the stud thickness, the spacing, as well as the depth by the architect? And perhaps you even have a table or a chart in your specification that shows what size stud to use where, or you put it into your firm puts it into the partition types.
Yep. Well, that's far fewer. Well, maybe 20% of those with us today. I'll go back to our clients, the ones that are saying we want the 33 mil studs, and that's all that we're going to take. By making that decision, the architect actually assumes the responsibility for that design because there's no other way to go about it. so that if the architect is selecting the 33 mil, it's the heaviest drywall stud he can get, and the span that he has to make is 16 feet, and he doesn't check the limiting heights to know that the 3 5/8 33 mil stud is not going to make it, the architect is on the hook.
I think the question is, the drawings almost always show that a partition is going to be, say, 3 5. They'll show partition types. They'll call out 3 5/8 studs at 16 on center. Sometimes they even say a mil thickness on the drawings. And then when it comes to the specifications, the same project may ask that that a delegated design be performed to make sure that the deflection is going to be within the acceptable range. How those two things get squared is often a problem because the drawings will show one thing and the spec will describe something else.
Well, and
fortunately,
yeah, and even in a case like this where they're already selecting the heaviest design, the heaviest stud, it's specified as 33 mil. And if they're showing 3 5/8, and that's what they've designed to fit, there's nowhere for the structural or for the contractor to go with a delegated design. I actually spoke with one of the stud manufacturers, and he had, in the case where we see often in casino work, especially on the casino floor, you might have studs that have to span 30 and 40 feet. Which means you're going to be in a structural stud. Well, the architect in one case had selected actually a 12 gauge 16 inch or 6 inch stud to do the span. And the 12 gauge, again, I'm going gauge because that's what he was telling me and I didn't go, but 12 gauge is actually 1/8 inch thick. It's really difficult to work with this stud. And they could have done it with an 18 gauge 8 inch stud. And if you think about the ease of working and even the cost of trying to go to a lighter stud, but maybe a little bit deeper, you can make up for these deflection requirements by considering the depth of the stud. It's an easy decision as long as that's available.
Yeah, so we had that a while back. We were working on an airport, and the main hall where people came in to get their tickets was on the order of 50 feet high. So, but yeah, we didn't use the 12 gauge studs by any means. Speaking of gauge and mills, Elias charted those out here so we can talk. And of course, the interesting thing is that in ye olden days, there was a 20 gauge drywall stud and a 20 gauge structural stud, and they were not the same thickness.
They are today. So there are two standards that apply, one for structural studs, one for drywall studs, and both include a 33 mil stud.
True, but there is also a 30 mil stud.
There is. That is a drywall stud. So, Elias, what did you find out here about the embossed studs? What are they doing with the thicknesses?
Well, they are decreasing the metal thicknesses. Apparently, the additional embossing adds just enough material stiffness so that with less metal, you can have this basically exact same performance. So a 18 mil standard stud and a 15 mil embossed stud basically can be used in exactly the same partition with the same performance. The narrower, the thinner metal embossed studs obviously weigh a lot less, will at least, well, over a load of studs, it's going to be a lot less, and contribute to lower transportation costs. Thinner metal, like David mentioned earlier, is better for acoustical separation. So going with the embossed studs can help with improving your acoustical separation. We found that some manufacturers now have a 30 mil embossed stud. It doesn't correspond to a gauge thickness. And actually, the whole notion of gauge thicknesses really needs to go away. The manufacturers all list their thicknesses in mils. Master Spec lists all the thicknesses in decimals, which is why I listed the decimals here. So if you're working in Master Spec, those are the numbers you're going to see. Kind of makes things a little bit confusing because the spec and the manufacturers are not really speaking the same language, although the numbers are the same. But so that's what we found with the embossed studs. It's they're an improved product.
But David has discovered an interesting thing about the total area of the steel and what the ASTM standards require.
You think? Well, we'll get to that, but
That's a little later. Okay.
Yeah, it's a little bit.
Let's talk. Yeah, let's talk about some of those standard accessories. We mentioned manufactured lintels, resilient channels that they're hat shaped, but you only attach one flange so that they can flex a little bit and absorb some of the sound without passing it through the studs. We have a couple of questions. Dennis Burge asks, he said he read an article recently that knurled studs are causing issues with fasteners and implied not to use the knurled or the embossed type of studs. Have you run across that, David?
I am not aware of that, and actually I think at least one of the manufacturers was promoting the embossing or knurl as a way to help grab the self-drilling screws and help
so they don't
keep it from running.
Yeah, so they don't walk and go sideways. And then Dave Metzger asks, does the thinner metal of the embossed studs affect screw holding capacity?
Good question, Dave. And I've done some investigation. I haven't done an exhaustive of all of the manufacturers, but I know that the results that at least one manufacturer is reporting, tested results, is that it's at least equal and in sometimes better than the standard in the case of drywall studs, 18 and 30 mil studs. So the screw pull-out is not an issue with the embossed studs.
If you think about it, the screw pull-out is less important than the shear anyway, because what we're trying to do is hold the drywall, the gypsum board on the wall that wants to shift downwards. It's not pulling it out so much as falling down.
Except that the pull-out is one of the ASTM standards. It's one of the tests that you have to perform.
And of course, nobody likes to see those popped nails in wood construction in gypsum board.
So one other thing on your list of accessories, I know I added this, the shelf bottom track. We discovered this recently, and we're actually suggesting it for locations where there may be issues with, call it flooding inside the building. Doesn't have to be much water, but it can be water that can get wicked up into gypsum board and start to cause mold and mildew growth. So there's a new proprietary track that actually has a shelf built in at the bottom to keep the drywall at least 2 inches up off the deck and help to avoid that wicking problem should there be any kind of flooding on the floor.
And you might explain that the face of the track comes out to the face of where the drywall would be, so that you can apply the wall base and so forth, and it's not like there's a void there, and then steps back to hold where the drywall is, and then goes up another inch or so.
Right. Yeah, so it helps prevent that, somebody running the buffing machine into the wall base and then kicking it into the void, and then you're never able to get it straightened out.
We need to move on a little bit, David. I'm trying to watch our time here. Elias put together this wonderful slide giving us the various options on how to do blocking or backing for wall-supported elements. Elias?
Well, this slide essentially shows the options that we found or that are typically used. The flat strapping method is very simple. You just take a sheet of metal and screw it to the studs. Usually not used for really heavy items, I think, just because if you're between the studs, the sheet metal is not going to stay flush against the back of the drywall, so it's not going to have as much weight holding capacity. Where the continuous track or the clip track method, it's pretty good capacity and easy to install. Just using wood panels.
And on the track method like that, of course you can buy track in 8, 10, 12-inch units. So if you need something a little wider than the typical 4-inch stuff, it's available, and that track can be quite a bit heavier gauge than the studs for your to improve your screw holding capacity. Yep.
And then using wood, the benefits are you can nail into it as well as screwing into it. There are numerous proprietary combination products that have wood clipped to this, that's between these clips that are attached to the studs, that are designed to be easier to install than just pieces of wood screwed to the back of the studs, and provide the same ability to both hold screwing in items or nailed in items.
And if there's any other concern, you can get FSC credit for some of those wood products. So if you're looking, you can help contribute to that lead credit. So
we have a couple of comments or questions from the floor. Scott Anderson, our friend from Birmingham, says, since the embossing is on the stud flange, would that have an effect on the acoustical performance? I doubt it, Scott. I don't think so. I guess it could be argued that less of the chipboard is in contact with the face of the stud. So it might have a minor amount of difference, but I don't know that anybody's tested that. Okay.
So one of the things I wanted to explore with everybody today, and this is my doing, so pardon all the engineering calculations that you're going to see, but this is part of the discussion I have with our clients about, well, what are you trying to accomplish when they're trying to tell us they are only accepting 33 mil studs? So moment of inertia of a section, in this case a stud, is dependent upon the area of the metal and the shape of the metal. So the moment of inertia is really talking about taking each area, multiplying it by the square of the distance from a point, whether it's the center axis or whether it's the base, it doesn't matter. You do the calculations, they all come out the same. But it gets you the moment of inertia, which is measured in inches to the fourth power, which is really a geometric property that tells you much about the resistance to bending. So in the case of stud manufacturers, when they're starting to use reduced metal thicknesses, it's going to affect the moment of inertia. So just doing the calculations for this one shape, and if we get a moment of inertia of about 17. And to give you an example of what happens, so if we take the thickness here, which I'm showing at a ½ inch, and we move it to 50% of that ½ inch, we're getting not a full 50% reduction in a moment of inertia, but about a 40%. So it does have an effect, and sometimes, depending upon the shape, it can have a dramatic effect. Moment of inertia is also dependent upon the axis of the stud. So we're showing it in the centroid of the C shape rather than the centroid of the flanges. And if you measured it the other way, it would be different. So how does all of this affect what we're doing? Because we're looking at studs that are really a simple beam, uniformly loaded, with the 5 pounds that Lewis had mentioned earlier, 5 pounds a square foot or linear foot, depending upon what the stud spacing is. So deflection only has 4 variables to control all of deflection. And we'll get into each one of those. You can affect any one of them and compensate by adjusting the other 3. So the manufacturers are really controlling E, which is the modulus of elasticity. It's a material property. So if they're going to select a specific steel, the modulus of elasticity is based upon the composition of that steel. The moment of inertia we just talked about is really a shape property. They can control that by the metal thickness.
And David and I are old enough to remember that before in ye olden days, the manufacturers steel studs, a given size stud, 6-inch curtain wall stud, for example, that the moment of inertia and the modulus of elasticity would vary quite a bit between manufacturers. And if you look at specifications from the 70s and early 80s, we actually used to specify a minimum values for these things to make sure that we were getting what was appropriate.
That was back when architects would actually select the studs.
That was the day.
Okay. So in the discussions I'm trying to have with some of our clients, it's what the designers are really controlling are the uniform load and the clear span. Now, I say clear span because if you take a stud that has to be 20 feet long and you can brace that stud above in the ceiling cavity, nobody sees the bracing, you just reduce the clear span. And you don't have the same concerns if you can reduce the clear span using bracing to get it below the maximum length, the unbraced length. So the designers do have some control. Depending upon what they put above the ceiling, they may be able to rely on bracing and be able to use a reduced stud size or a reduced stud thickness. So, Lewis, you mentioned some of the typical kinds of stud loadings that we're seeing, and I don't know that we actually have anybody that's designing unducted shafts anymore. It used to happen where the shaft wall was actually acting as the duct. I don't even know if it's permitted anymore.
Probably not.
But the elevator shafts, certainly, we see that just by the elevator movement. And the stud manufacturers are giving you choices for these as standard choices because it's coming out of the ASTM standard for studs. So you get 5 pounds a square foot, 10 pounds a square foot, and to keep everybody happy where they can't make up their mind, you get 7.5 pounds a square foot right in the middle. So looking at some of the a typical kind of a healthcare floor to floor where we might have a 14-foot span, really common. What sorts of deflections might we actually get if we go to the maximum allowable.
So the first one would be for just a painted wall or a wall with wall covering or some other flexible finish on it.
I wouldn't do that.
It's a little bouncy.
That's a lot of deflection, 1.5 inches.
That's a little bouncy.
And that's likely to open up gypsum joints, if you ever got close to that level of deflection. So L over 240 is common for gypsum partitions. L over 360 might be more common for tile finished partitions. And part of the reason is that TCNA is actually, until this most recent 2018 edition, has actually required 33 mil studs for any tile-faced partition. They've eliminated that requirement. Now they're putting in a caution indicating that the ANSI standard for cement backer boards requires 33 mil, and that you should be looking at the capacity if you're going to any of the embossed or EQ studs. Oh, that took a little while to focus. So I took a snapshot out of C645. That's the ASTM standard that actually governs steel studs. And you can see I'm looking at studs here that happen to be 4-inch deep studs, and it's showing 18 mil, 30, and 33 mil studs. And the minimum properties for each of those studs. Part of the way that the stud manufacturers are able to cope with this today is the same standard, C645, includes the clip at the bottom. And if you look at 9.2, essentially it's saying, hey, if you can prove that studs of different minimum properties comply with the performance requirements, that you're allowed to reduce section properties, you're allowed to reduce the minimum thicknesses, but still provide the same performance. So this is in what the manufacturers for all the embossed or the studs and with the reduced thicknesses are relying on. And this one, I've actually clipped a piece out of the Viper or Merino Ware catalog. And I want to just use this as an example. So here's at the top is the ASTM standard, the minimum requirement. And again, I stayed with a 4-inch stud. That the ASTM standard says at 16-inch centers, 5 pounds a square foot loading, the stud has to have a limiting height of 1311. And Merino Ware is able to give nearly a foot greater limiting height with a 15 mil stud. With a 15 mil stud. So I think that that's really important to realize that the manufacturers are trying to give us a better performing stud, less thickness, and again, less weight shipping to the site. So there's some savings there. Rest assured, they're probably saving money in the manufacturer, but they're delivering a product that's actually performing better.
So the Viper stud is a 70 KSI, or is that a 50 KSI?
In the 15 mil, I believe that they are at 57 KSI.
57.
And they just did introduce a 70 KSI, but I believe that's in the 18 mil.
Okay.
So they are using a variety of steel strengths. We've seen 50, 57, and 70 KSI, where the standard strengths, according to ASTM, are all based on 33 KSI. And that's part of this balancing act to be able to control the deflection. So they're adjusting the modulus of elasticity. They're adjust to compensate for the lesser moment of inertia, and they're actually able to deliver a better performing stud when it comes to deflection. So where can we send our listeners for more information, Louis? I think you dug most of this up.
Well, there are actually 4 kind of somewhat competing stud manufacturer associations. The SSMA, and their product technical guide is a ICC evaluation services report that can be, and states that everything in it allows you to conform to the requirements of the code, and that's free. You can get that downloaded, and a couple of the details that Elias showed you are also free downloads as PDFs. Then there's the Steel Framing Industry Association, and there's its. You don't need, folks, you don't need necessarily to copy all of this. We will be providing a PDF copy to Matt folks, and that you can have access to it sometime next week. And again, they have a technical guide that, like the SSMA guide, has load and span tables. And they have an interesting technical paper about the EQ wall studs. There's a Certified Steel Stud Association, and it doesn't have much in the way of free information other than just evaluation reports from the 2 member manufacturers. The Steel Framing Alliance seems to be more of a kind of a general industry promotional group rather than anything else, and so they have some technical and promotional documents, but for example, they distribute the SSMA technical guide that has the load and span tables. And finally, one that surprised me because I had not heard of before, but managed to round it up, is the Cold Form Steel Engineers Institute. And they have free downloads of all the AISI, the American Institute of Steel, documents that relate to stud framing. So if you want to build up your library, you can download those PDFs. So there's lots of stuff out there. We just need to figure out how to use it best.
Which brings us to the end, just about on time.
Just about on time.
A couple minutes early.
We done good.
So we're looking at next month's timing for our meeting, and we're a little bit uncertain, mainly because of May. We would normally be doing the next meeting August 2nd, our first Thursday in August, but I will be busy attending the birth of my 5th grandchild that day. So I am not going to be available. Those of you that would like Louis to do the next month's meeting on his own, please raise your hand.
Oh, that's dirty pool.
Oh, but hey, I had the last shot here, and it looks like you're getting an overwhelming majority, Louis.
Okay, April the 2nd it is. August the 2nd it is. Maybe I can enlist Elias to help me out, or we'll see what happens.
So realistically, folks, we're going to take a look at this and see if we maybe need to postpone 1 week and get it pushed back to August 9th. I'll confer with Louis, and we'll let you know soon.
Well, thanks everybody again. And if you have a suggestion for the August presentation, please keep those cards and letters coming in, friends and neighbors, because as David and I try to say every month, this is really your program, and we want to do what you want to know about, and we want to provide some information or guidance, or at least set you up to ask the right questions. So if you have some suggestions about programs, please let us know, and we'll try to accommodate you.
Okay, and I want to take one last opportunity to thank Elias for his contribution, because it was really helpful to have him participate, and I'd like to thank him publicly here for that participation. So much appreciated, Elias.
Yeah, happy to be here. Thanks for inviting me to help out.